111. Okay. Hey, hello, everybody. How are you? Good.
Hi,
Great.
guys.
So today we have two great speeches, or at least one. I shouldn't judge my own speech, so I don't know. But we've got two speeches. First one will be from Cloudinary by Michał and Avihay, and they will be talking about cost optimization in S3. And well, do you have anything to add?
I think you are right.
Yeah. So yeah, let's give us mic to the speaker, I think. Or do you want to say anything?
Firstly, I'd like to welcome you very warmly because we haven't been on the market of meetups from October, as I remember. But here we are, and we are very happy that you are with us today. And
let's start. So let's give a round of applause for Michał.
Yeah.
Thank you, Paweł. Thank you, Maria. I believe, Paweł, your presentation will be great. So the second one. Okay, so which one of you recognize logo or the company you can see on the screen? No one. Okay, I'm also ready for that. So I'm representing Cloudinary, and the plan for today is first we have one slide about me, then 5 minutes about Cloudinary. I will explain what we are doing and how it started, and then I will give the stage to Avihay. Avihay will continue with the main topic. So first about me, my name is Michał Sordyl. I work for Cloudinary for over 4 years. I'm team lead. I have my small team. Actually, more the front-end guy. You are probably more back-end oriented or infrastructure oriented. So please don't kill me with technical questions here. And that's me and my daughter and wife. That's what we are. And on the photos on the right, you can see what I'm doing in my spare time. We're riding bikes. I'm building things with wood, and I'm making holes in targets. Right. And now Cloudinary. So history of Cloudinary started in 2012 by 3 developers who couldn't find a solution for media management. They couldn't find a tool on the market that will suit their needs, their business, right? And they decided, okay, well, it's time to create this business. So they did, and it worked pretty well. So what we are doing in Cloudinary, we are API first image and video optimized delivery platform. We are delivering media to internet, to websites, to mobile, to devices also. Like, okay, that's not my slide. There it is. Great. Thank you. And we are helping customers to deliver it faster, better, and easier. And talking about customers, now you should be able to recognize some of logos here, some big brands. We have over 10,000 customers, 3 million developers, and billions of assets in our digital management. So what we can do with the images? We can optimize them. We can use a simple URL, simple modification in the URL to deliver the same image, or well, almost the same image, because it's 3 times smaller, and you cannot find a difference between the images, right? The quality is still that good. That image looks great on the website. You can also modify images. You can apply filters. You can add overlays to the images. You can crop images. All of this, really, all of this you can do by modifying URL to the media. So you have one image stored on your storage space, and you have different versions of the image displayed on your website. But that's not everything. We also have some smart features. Here there is an example of G-Auto, and you can focus and crop part of the image which is interesting for you at the moment. And that thing works not only for images, but also for video. So you have landscape video, and you are watching this video on the phone. You don't want to see entire video because, well, nothing happens on the left and right. The only part of the video is interested. And thanks to our G-Auto function, you can focus on the main part. So if you're interested in that, you can create a free account in Cloudinary. We are giving you credits you can use. It's probably enough for a small website, like hobby website. It will be enough. For bigger business, we have paid plans. And now Avihay with his topic about optimizing S3 on AWS. Avihay, are you ready?
Have a moment. I will share my screen.
Yeah, let's give us a second.
Guys, do you see my screen? I don't hear you.
Let's wait a moment. Second.
Okay.
Screen.
Do you hear me? Yeah.
Yeah, we can hear you, and there's a screen on. It's visible, so you can go.
Let me see. I'll go to my screen to see if I see it. Yes, I see it as well. Can I start, guys? So I'm starting without your permission. Good evening, Krakow. I will walk you through today of our journey with saving over $1 million year over year. So it's not just 1 year saving, it's going and even getting bigger from year to year. I'm very happy to be with you guys. Krakow is one of my favorite cities in the world. I think it's amazing city, and I was very anxious to come to Krakow, but unfortunately I can't. So let's start with the journey, guys. So about myself a little, I'm a high-tech veteran. I have decades of experience. I was a developer, manager, architect, worked on DevOps before DevOps was called DevOps. And I'm in Cloudinary over 5 years. And FinOps is kind of baby of mine in Cloudinary. I started with kind of a FinOps course in Israel, which one of the companies in Israel organized for free, and everyone could join that. This was a very educated one. And from that point on, I took it, and I spent a very little time every day. And I think I can take the last half year about between $2 to $3 million saving year over year. So every day I found something and fixing or asking people to fix. My role today is as a floating role. I'm moving on in the infrastructure group between DevOps and SecOps platform, and there is a new AI productivity team. So I'm moving on all around. So the problem we're talking about, Cloudinary, as you know, it's managing and optimizing and delivering images and videos. Clients' assets are kept in our S3 bucket. Most of them, they can bring their own, but most of it is kept in our S3 bucket. So we keep it in one bucket. It's not only the assets, it's all derivatives. So what you saw, an image that was changed, a video that was changed, every part is kept in our S3 bucket. Not only that, we are doing backup. So you can imagine yourself, companies like Nike or others, that they have billions of images and videos, and that's got into a petabyte of data. So that's huge amount of data. And one day our manager came to us. We were a new team. It was about 4 years ago, and says, guys, can you do something about the S3 cost? S3 is our largest cost by far. And we didn't know much about S3. So we knew, but not about cost of S3. We knew how to work with it. We knew that Glacier is more expensive with retrieval, but not too much. So we scratch our heads and said, okay, can we do something here? And the first thing we said, let's find the big growth. Let's do very little work and get as much as we can out of it. So how we tackle it, how we start investigating it. So we have a few toolkits to do it. The first one is storage lengths. I hope everyone knows storage length, but if not, you can, when you enter S3 in the main screen, to the left there is storage lengths. You can create dashboard there, and there is free tier, okay, and there is paid tier. We use both of them. So storage lengths, by the way, the paid one give you more options, but most of you can live with the free one, and it's a very good one. To get cost, there is cost metrics, cost optimization metrics inside. So you have to choose it and to find how and to find out these metrics. But go in. It's very easy to understand. Learn storage lengths. It's a very nice tool. I didn't know that about it before, but I think it's a great tool. But the major difference between the free and the paid is that the amount of time. The free is for only 14 days. The paid one can have data for 15 months. He has much more metrics, 60 compared to 28. You can have data by prefix, so you can compare prefixes. It gives you recommendation. It has CloudWatch metrics. The paid one is very expensive, but gives you more information. Most of you, as I said, use the free tier, okay? The other one is access log. Access log, we'll talk about it more later, but give you information about the access of every and each object. You can export it, ask to export it to S3, which is the cheapest way. You get to S3, you can then crunch the data and find it has all the data you need with access log. But you need to work for yourself. Last thing that I added, it's AWS flow log. I don't know if most of you are familiar with that, but flow log, it's a network tracing, and you can add it to the whole VPC, which is very, very expensive, but you can add it to a specific network card, and I will talk about it again later. So this is the tool to analyze our data, but we need to understand what is our cost, what is the access cost, the patterns, and the retrieval cost. So let's go over a little bit about the tiers of S3. It's not all of them, but this is the important one, the standard one, which most of us uses, and then the infrequent one, which the AWS recommend if you access one in 30 days, Glacier instance retrieval, and then the other Glacier family, which not too many people are using, or using it for data that you keep for a long time, and not most of the time you're not accessing it. The pricing, you should understand, the pricing of standard, the cost of storage is higher, but the API cost, the retrieval, and moving from tier to tier is cheaper. So let's a little go see the pricing. If you can see the standard, the storage is higher than others. Okay, see that the infrequent is almost half. Okay, and Glacier instance retrievals is 1 to 5, okay, 20%, about 20% the price of it. But you can see the get API, put API, the lifecycle transformations, and retrieval are much higher. By the way, to understand the cost here, the put, get, and the lifecycle are for 1,000 of objects, okay? The 1,000 object access, the retrieval gigabyte, storage is by gigabyte. As you can see here, you can see the intelligent tiering. The general tiering cost is per 1,000 objects, okay? This is the cost per 1,000 object. There is inventory report and more other interesting costs. Learn it, understand it. So we did it. So let's go to our first case. I think it's the more fascinating one, or the one that really shocked me. So the story behind it, that we had a new product. Cloudinary launched a new product, and one day they came to us as the DevOps and say, hey guys, can you create for me a bucket with a versioning for that new product? Okay, we created it. And then after 1 year, we start working on the pricing and the cost. We didn't see anything special. We saw the bucket is cost money. Yes, we're regular because we have petabytes of data. Okay, we were one of the first companies to have few petabytes of data, and we didn't see anything about it. And then we drill down into storage length. We went into storage length. We activated the cost optimization metrics, and I want you guys drop numbers. Mihao, can you ask the people how many percent of the data was non-current? If anyone can guess, maybe 3 guess. Mihao? Any guesses? Do you hear me?
Yeah. Okay.
Any numbers?
80%.
80%. Another one. More? Any guess? No one want to guess? Okay, I will continue.
100%.
Okay. The 100% is the winner because it's very close. It was 99% of the data that was non-current. More than that, it was even most of it delete marker. So I will explain. The new product was the difference between this and the regular one. It's deleting object very frequent. Okay, so when you enter an object, it's the life cycle. It was very short, so we deleted the object every few weeks, or it depends on client, but it was very short lifetime. They have a short default, and most of the objects were deleted. But when you go to the bucket, when a versioning is activated on the bucket, you won't see the object, but it's still you're paying. So you pay for each version. So if we change the object, each version is kept there, and if you delete, it's still all of them are still there. So the delete marker is something that I said how AWS did such thing. We couldn't see that, but you should know about storage length and understand that this is the way. So how you tackle that, and before how we tackle that, you know what my first thought about it? We are complete idiots. Yeah, I felt like an idiot. How could we do such a stupid thing? I really felt that, whoa. But you know what I said? Hey guys, we save a lot of money. We're great. I'm joking, but yes, we can. This hit me. This was a stunning thing that we found. But how do you tackle it? What are you doing to avoid such cases? So to fix it, there is a very simple life cycle rule that you can expire non-current version. So you ask your legal client, or not the client, but the developers, to tell you for how long we must keep non-current. So we add the lifecycle rule, and bam, 99% of the data was gone. We save here a lot of money, and I really felt stupid at the moment. I said, wow, how could be that we didn't know about it? We didn't realize that. We didn't know the product. But this is the first case. Let's go to the second one. Cloudinary, as I said, keeping the data of the clients, okay? But we are doing DR as well. So we are writing every object to two buckets, to the main bucket and to our DR bucket. The main bucket is USys1, the DR is USys2. And then we look at that and say, okay, what can we do that? And we went to our data and to understand how are we accessing the data? And we realized it was pretty simple. We realized that we are rarely accessing the data in the DR. So we are accessing the DR only if we try to access the bucket at USys1 and we can't access, so we go to USys2. In that case, we understand we do not need the regular tier. So we move all the object to Glacier Instant Retrieval. Okay? How we do it? The first thing we did is a lifecycle rule that moves every object to Glacier Instant Retrieval. So we pay the penalty for these all objects that were there for the lifecycle rule. But later on, each object, we put it immediately in that tier in Glacier Instant Retrieval. Why we put it there? Because if we let the lifecycle rule to do it, we're paying twice. We're paying for putting and then for the transition. That way, we directly put it in lifecycle rule. Keep it in mind. This can save money. We had another bucket, just to understand, we had another bucket for logs and data of a big data thing, and there we had a similar case when we knew exactly for how long we need to keep the data, what the legal cell, what the data team, and we had the lifecycle rule there, different one for each prefix, and that we save a lot of money. Just to compare with lifecycle rule, you can do it by a prefix or by size or by tag on the object, the combination of all of them. If there is no, if the lifecycle rule has no a condition, it will take all of the object in the bucket. We're ready for the third case and the most complicated one. So we are back to our main bucket. Our main bucket is huge. It's bigger than the DR. Not all objects are kept there. And there are many, many clients. So if you try to find a pattern, you won't find it there, okay? The access to the bucket is each client is differently, and some of the objects, and even with clients, some of the objects are almost never accessed. Some of them are immediate access and for very long time accessing day after day. So it's hard to find a pattern. So what we did here, and we took storage length and the paid one. We add the storage length, the paid one. We as well took the metrics of storage length. Our data team analyzed access from the application and from other metrics. We work very hard to understand what is the pattern here, and this was the most risky one, because we're talking here about our main bucket. We cannot make any changes that affect the behavior of the client or make any latency, or will lose data. This is the place that we could not do anything stupid so it took us some time. We learned it by heart, and we understood where we're going. So the tool here is intelligent tiering. Let's a little compare intelligent tiering to lifecycle rule. And a moment. Cheers, guys. A little beer. intelligent tiering compared to lifecycle rule. Intelligent tiering, you put it on object level. It's like other tiers, similar to other tiers, which you paid by the number of objects it's monitored. Okay, so the number of objects you put it intelligent tiering per 1,000 object, you're paying, and you saw the prices before. You can look for that. Lifecycle rule, you pay for each transition. Okay, so if let's say before, when we have the bucket and USS2, the DR one, after we did the first transition and then put each object in a Glacier instance retrieval, the lifecycle rule shouldn't affect any new object. Okay, so we are not paying. Unlikely intelligent tiering, which you're paying for monitoring the object. AWS are not monitoring under 128 kilobytes objects. They used to charge you for that before, and they are not charging anymore, so you don't have to worry about that. And the balance here is between the transformation, the size of the object, because if you're for a very small object, the save that you can get is not worth the monitoring fee. So what AWS exactly do here? They took an object, they're looking at the object. After 30 days of inactive, which means you didn't get object or look or copy or similar that accessing the object data, it moved to infrequent access. Why 30 days? If you saw at the beginning there is a minimum time for storing in infrequent access. If you store in infrequent access and delete it before 30 days, you will pay the whole first 30 days. There's a minimum time to stay in the infrequent access. So after 30 days, move to infrequent access and then to Glacier instance retrieval. Glacier instance retrieval, it's 90 days, so you get here. The moment you access the object, it's go directly back to the regular tier, okay? And the good part of it, you are not paying for moving from tier to tier, and more than that, you're not paying for retrieval fee. So if you reach Glacier instant retrieval or infrequent access, we saw there is retrieval fee per gigabyte, you are not paying that. So that was amazing, fits our needs. We paid about $200,000 for the first move. So we add the lifecycle rule to move all the objects that are larger than 512 kilobytes. That's our sweet spot. And we move all those objects. It costs us $200,000, but in 3 months, we got all the ROI was 3 months, all the money, and it was amazing reduction. We are very happy about that. As you understand, it's continue, and we continue with that. So tips for from this specific case, and remember, learn. There is minimum duration. That this is one of the things that you remember. Know what Glacier instant retrieval, what is infrequent access, the minimum object size for intelligent tiering. You are not paying for the retrieval fees. So after doing that, and I think I covered the three main cases that we had, I have a bonus one for you. The bonus one, we in Cloudinary, and I think many other companies, we moved from public subnet to private one. The reasons are various. First, it's the best practices to work with a private subnet, but we used to work with public. One of the major thing is cost. When you work with a public subnet and public IP, you go directly out from your machine to the internet. So you're going directly to the internet gateway. But if you are in private subnet, you're moving from the machine or the network card in the private subnet to the NAT gateway, and from the NAT gateway, it's reaching the public subnet. NAT gateway is very, very expensive. Why? I don't know, but they cost 4.5 cents to 1 gigabyte each way, okay, in or out. And when we want to move from the public to private, we wanted to understand the effect on us. And what we did, we added a flow log on the network card of the NAT gateway. So what you see in the flow log, you see source IP, target IP, the size of the data that was transferred, and you see a timestamp. This is most of the important data. And if you look at the whole logs, you can see that all of them going to the NAT gateway and from the NAT gateway, okay, from IP of NAT gateway. NAT gateway is a public IP and private IP. So we arranged the data like that, and we saw which subnets doing the most call to the gateway, okay? We summarize it by subnet, we summarize it by the target, okay? And not only that, we took the target and the target public IPs, and we took out the host they are going to. How we do that? We call the public IP, we made a call to the public IP HTTPS, and we just took out the certificate that they returned to us. It's all failing, but we did a cache of certificate. So we knew each IP, target IP, public IP, the actual host they're going to. So that way we could summarize the amount of data going by day to the S3 buckets. Not only that, we knew the regions, because I hope everyone knows S3 has gateway VPC endpoint, which you can do to the same region you are working at. Gateway interface VPC endpoint is free of charge, okay? And that way you are not going to the internet. So directly from your machine, you will be transferred to that VPC endpoint to S3, not going through the internet. But this is for the same region you are. And now what I realized, we are going to other buckets, clients buckets. Some clients have buckets, and the most dominant bucket was, you should guess, it's the USS2, our DR bucket, okay? So how would we solve it? On November 2025, AWS declared a interface VPC endpoint. It's unlike gateway VPC endpoint. It's interface, it costs money, but you can have interface VPC endpoint to another region, which means you can add a region, let's say USS2, and then your traffic won't go through the NAT gateway. As you can see, when you're going through NAT gateway in the regular way, you will pay for the 0.45 and for the NAT gateway, and another cent for the inter-AZ. So you're moving from AZ to AZ. On the other way, you're paying 1 cent for going through the interface VPC endpoint, and another 2 cents because you're doing cross-region transformation, or cross-region data sending. So you're crossing the region. So you're saving here money. For guys who are really, really brave, or maybe very technical, there are 2 projects to bypass NAT gateway at all, okay? There is one which called FCK NAT, or what we call it FAC NAT. This is a naive solution that will allow you to bypass the NAT gateway. Okay, it has a Helm chart. It has many things that will allow you to create it. Very nice one. And there is a more robust one which called Alternate. It's done a very complicated way to allow zero downtime, because the FACNAT or FCK NAT, you will have some downtime when AWS will replace your machine. The other one doing a better job with that, but this is only for brave one. I wouldn't do that in Cloudinary because the volume of our traffic is huge, so we cannot take that risk. So remember, new coarse region interface VPC endpoint and NAT gateway. It's cost a lot. I think we got to the question and answer, and then if we will have time after that, I can add another a few words about access logs. And again, cheers, guys.
Okay, thank you very much, Avihay. Let's give a round of applause. Great. So,
Okay.
do we have any questions? Okay, here's one.
Yeah, first of all, thank you for presentation. Question about intelligence peer. What about like delays when the object goes from deep archive to standard one? Any of them?
There is no delay. Glacier is if you move to deep archive, there is Glacier Instant Retrieval. We didn't go further than Glacier Instant Retrieval, but if you are going to the deep archive, there is a delay for retrieving, but AWS offer you to pay $100 a month to get it fast. So if you want to pay that, you can do that and pay them $100 a month for accessing the deep archive, the other deep archive, faster.
Yes, thank you. No, the question was about intelligence tier.
Okay.
So when object is moved from the last one after 19 days to the standard frequent access, is there any delay in access or not?
No. All three, the standard access, the infrequent access, and Glacier Instant Retrieval are millisecond to get them. All of them, three of them.
Thank you.
Thanks. So, do we have any other questions? I can see here one.
Thank you. Oh, thank you. I have two questions. First of all, in case some company works with the media data, usually we have like two service hands in hands. It's like S3 and CloudFront. And yeah, in case it's a huge amount of data, for example, some video data, usually it's using with the CloudFront, and the amount of the cost of this CloudFront sometimes is higher than even amount of S3. What is your recommendation about this cost optimization for CloudFront and in pair with the S3?
I can tell you what we are working with. We mostly work. We are working with 3-4 companies of CDNs. Okay. But when we work with CloudFront, and if you reach a high pricing, there is what people call private pricing. So when you have a contract with AWS, you can negotiate about pricing of something that is very high. So we have private pricing for S3. Okay. We even have private pricing for CloudFront. We did that to save money for the outgoing traffic from the load balancer was very high. So now we're moving through CloudFront. It's cheaper for us. So this is the way so you need to analyze it and see if it's worth thing. If it's that high price, you should use some kind of caches or layers even before CloudFront or CloudFront to do some caches that can be cheaper. So, but it's really need to go deep down into details, understand specific one. The first thing I would do, if it's very high cost, try to work with AWS and get private pricing for that for your contract. Okay? But if not that, try to get cache something for that.
Okay, thank you. And second question, what is your recommendation about alerting in the S3, regarding the S3 and regarding the cost? Do you have some recommendation of alerting based on the AWS CloudWatch or some another system inside the AWS?
We don't have such. You can create one from metrics of S3 or from access log. You can create. We didn't do what I'm using cost explorer and anomaly detection, which tells me there are changes. Okay, I'm checking on daily basis, few minutes a day, checking those metrics and checking how things change. But yes, you can create such. It depends what you want to watch. So if something worth, if I had some case that it worked for me to watch it, I will create monitoring for that. You can create, there are a lot of dashboard that you can create from the queue, the queue report. You can create dashboard for that. You can do kind of data warehouse from the queue report and watch it on daily and create from that your alert for cost. But I didn't create, beside the anomaly detection, I didn't create any alert for that.
Yeah, thank you.
Great. So do we have any other questions? Oh, there's one.
Thank you for presentation. I have a question about versioning. You said you have had a lot of non-versioning files,
Right.
99%. So
Yeah.
my question is, how? I assuming you somehow, for some reason, that feature that was enabled, and I want to understand how you distinguish between genuinely dead versions and between the version that's really needed for rollbacks and compliance.
Okay, that's a good question for a compliant question. So we, what we did, versioning, keep all version and keep it for a long time. Let's say I have a bucket of Terraform and I probably would like to Terraform state to keep it forever. But for that specific product, which was 99%, we had an agreement with the client and we went for that agreement and see for how long we keep a version. Okay, we must keep a version. And then we add the lifecycle rule to delete this, all those that older than that day. Okay, the number of day. So it's it's something that is part of the product. What we are committing to, our commitment to the client, and that was it. So we just had to ask and get the information about it. Okay, other thing, it can be compliant, right? If we are logs, if the regulatory asks us to keep logs for 1 year, so we will do it after 1 year. Okay, if it's not version, other life cycle rule. Okay?
Thank you. So do we have another questions? Oh, Michal has a question. Okay. Let's go.
So Avihay, you mentioned private pricing and $1 million optimization.
Yeah.
So what's the scale of payments we are making for AWS, like monthly, yearly? Can we reveal some numbers?
I can tell you that we are paying over $1 million per month overall, about more than $1 million per month to AWS.
Thank you. So that's the scale we are dealing with here.
Yeah, it was much more. I can say that since we started with doing optimization all over AWS, we reached the lowest cost since 2021. Okay? Just to understand, it's not only S3, but we reached the lowest payment, and we grew by I think 30% yearly. So you can understand that we grew. We are doing more and paying less. Do you want me to finish my lecture or any other question?
Okay, we have one more question.
Okay.
I assume you split your infrastructure between many regions. How do you deal with do you synchronize this automation of moving data between the tiers of the S3, or it's separate for each region? Or how you deal with it?
Yeah, you're talking about regions?
Yeah.
Okay. We separate it.
Sorry for interrupting. In terms of data recovery, it's one part, but in terms of daily operation, yeah. For example, if the file is stored in the US 1, it's the same rules in the US 2 or something like this.
Okay. We separate it. US 2, we did all Glacier instant retrieval always. Okay, because we put, but we almost never access. And in use East 1, we have intelligent tiering. But we keep both of them. So the deletion is done simultaneously, okay? When we delete it simultaneously, we create it simultaneously. So it's only depend how we retrieve and what the tier. But all the tiers in intelligent tiering, all of them are millisecond access. So you don't feel the difference, okay?
Okay, thank you.
Great. So I think that's all the questions. Yes? Yeah. So we have time. I'm not sure.
If we
I
don't
think it's time for break.
Whatever you like.
How much do you have, Avihay?
2 minutes.
I think we can do 2 minutes. Yeah, let's go. So share your presentation and let's continue.
Okay. Do you see my presentation?
Maria, please add. And yes.
The last tip is really the best way to monitor your S3 is the access log. You have all the data that you need. The API call, the object, the path to the object, HTTP status, the IAM role that access it, the byte sent, object size, total time, failure, versions, user agent, and lately AWS added the source region. So they have cross region now. They add the source region. So they're adding almost everything to that. Beside the S3 bucket, the cost for the data that you're keeping, there's no extra cost. So it's very cheap and you got all the information. So use that if you want to monitor, if you want to find out everything. You can get the number of times someone accessed object, who was accessing, and everything you got there, use it. I think it's can be the best alternative to storage length. And let's summarize our travel and see our track. First thing is learn cost by heart, not only S3, everything. Understand the cost, the structure of the cost, how AWS taking their fees. Let's say network. I'll give you an example. If you're using network, traffic out from AWS costs you about 9 cents, okay, for gigabyte. It's a lot of money. If you don't know that, you will pay a lot of penalties, okay? By the way, when the only thing they exclude this 9 cents is when you're accessing data in S3, even if you're going to the world and not going through a VPC endpoint. But you need to understand the cost, learn what they're charging you for. The second thing, know your usage. When you know your usage, you will know if you are using intelligent tiering or lifecycle rules. You need to do nothing and things are going to. So know your usage and work accordingly. Third thing is the big rocks. Don't look for very small saving if it's not low-hanging fruit, very low. So it's not worth. Human time is much more expensive. So find your big rocks where you work less and get a lot of payback. And the last one, plan the ROI. Understand the ROI. If the ROI was 20 months or 40 months, I'm sure that the big cost of could sometimes it's not you cannot afford yourself to take out immediately, let's say $200,000 or $1 million immediately and wait for getting back. So understand the ROI and calculate your break even. And good luck for you guys in your journeys. Hope you find this interesting and you can save a lot in AWS costs. We do it on a regular basis. And again, thank you. Thank you all.
Oh, thank you very much. Great. Leif Avihay, I had a question. Yeah. Yeah. So one more question, because I got curious. Server access logs are really free?
Yes.
Oh.
Yeah, they're not charging you for the access log itself, only for the storage that they're putting in it in S3.
Yeah. Oh, every day you learn something new. So thank you again for a great presentation. Thank you also, Michał. So now we will have around 5 to 10 minute break to get ready for the next speech. And in the meanwhile, you can try our quiz. We will show the QR code in a second. It's a very complicated procedure. Okay, so thank you, Avihay.
Bye-bye.
Thank you for your time and have a good evening. Okay. Zły ekran. Możesz przerzucić ten. A second.
Almost there. Okay, I will hack it.
Great. Okay. So you can join the quiz. For the quiz, as always, there are rewards and AWS vouchers. So I think it's worth it. And yeah, do you want to say?
Meanwhile, we'll still have 2 gifts for audience, right?
You want to do it right now?
Yes, because I spot 2 people from the audience who actually were
Okay.
involved in the discussion. So why not?
Okay, so also we have gifts from Cloudinary, and they want to reward the most active questioners. So who have you chosen?
One for you. And here, right?
Who would say no?
I would take one too, but well, it's not enough.
Okay. Do you wanna give more?
I just want to add that you still have a chance to be active because Paweł will have his own speech, and also your questions will be awarded.
Yeah, of course. It's not the end. Okay, so yeah, 10-minute break. Let's get something to drink, something to eat, and we will prepare the next presentation. Thanks. Okay, so let's start our second part. And this time, well, I will be announcing myself because this is my presentation. So I'm gonna talk a little about S3s, but from security perspective. And to be more exact, we will be talking more. Can we turn off the music? Maria, can we turn off the music? Music, turn off. Yeah, so we'll be talking about buckets, but this time more from offensive perspective, so how we can break them. And for those who don't know, I'm Paweł Kusiński. My daily job is to break things for fun. And well, let's go. So first, short notice, I'm here on private matters. It's not my employee decision or something. I'm not representing anybody's view. And all of the URLs you will be seeing in the presentation, I've got all of them at the end in one QR code, so you don't need to do 50 camera shots or something. So just keep calm, everything will be there. So first, why this topic? You can think that, well, basically buckets exist for like 20-something years. Everybody knows that there are problems. Anybody knows how to fix them. Well, I'm not so sure that everybody knows that, because there is even a repository which sums up every leak. And there are like at least one leak per year. And by leak, I mean leak in thousands. So this is still an issue to this day. I would say even if you know DNS haiku, that S3 are more like DNS, but with data leaks. That's always if there is data leak, there is S3 included. So let's make short introduction for those who don't know. Well, I won't be talking what is S3 because I'm assuming that you know it. But first thing, maybe you didn't know, is that S3 was a first AWS service. And because of that, there are a few weird things going on. Because if we will go into access control, how do you think, what was the first access control in AWS, in S3? Nice. Yeah, ACL, because S3 existed before IAM. So there couldn't be an IAM policies. Of course, we had ICLs, then there was IAM, so we obtained IAM policies, also resource-based policies, so bucket policies. In the meantime, they were added pre-signed URLs, and I believe in last 2 years, there's also S3 access grants. And all of those can live in the same moment, give different accesses. So as you can right now see, it's already starting to be pretty complicated if we want to use all of them. But it's getting a little bit better, because I believe 4 years ago, Amazon allowed us to disable ACLs. So that was a first win, because we don't need to care about ACLs. Then they made it by default, because people were still using ACLs and were still leaking data. And one of the newest additions is that we now won't be able to use server-side encryption with customer keys by default, because it was also used in attacks for ransomware. So there's a lot of nice changes. But let's talk what can even go wrong with S3. What are the impacts of S3? So what do you think is like the biggest thing can happen when the bucket is, for example, public? Any ideas? Yeah, like, of course, leak of data. And it can be because of publicly exposed AWS keys, roles, because we've got wrong policy, wrong ACL, or just misconfigured present URLs. For example, if our application generates present URLs based on user input, maybe the user can just try another path and access other files. There are other things that can happen which are also not so funny for organizations. So, for example, removal of data. Especially if we are dealing with compliance, removal will be disastrous. If we are, well, parsing even user data, removal can end with, well, the end of our company. There was even something like that, I believe, 10 or 15 years ago, when one of the attackers just removed whole cloud environment of one organization, which basically made them, well, they never stand out. So the removal can be done not only by deletion of the data, but even with permission like being able to write files, we can also remove them just by writing the empty files. Or we can use ransomware, so we can encrypt them. And there are different methods which we'll be talking about later. And there's also overvision of the files. And by overwrite, I don't mean removal this time, but rather, for example, changing JS files which we are serving to our customers in case if we are some SDK, if we are sharing some SDKs that would be shared to like a lot of web pages. There's also an option to poison infrastructure as a code templates, like for example, TF states or templates for CloudFormation. Or we can even take the subdomain, and all of those we will be talking about in a moment. What we won't be discussing is phishing. So of course, if somebody have access to our bucket, he can try to upload some phishing data, try to like host from our bucket a phishing web page to like make this web page more believable by showing that it is from like your company. We won't be talking about uploading and redistribution of malware because, again, if somebody has access to your bucket, he can try to upload those files to your bucket to serve it from your buckets. Then it will be your problem when police comes. And denial of wallet, because if somebody has access to your bucket, he can try to upload terabytes of data. Then, like, for example, download it, upload it again, and in the loop, waiting for your bill to come to like thousands or hundreds of thousands of dollars. But like, why it even happens? Like, I even showed you that there are pretty good defaults which are blocking public access. There are defaults which are disabling ACLs. Why this is still happening? So first thing, probably companies don't have buckets from like last year. They still have the buckets which were created 10, 5, 15 years ago. And those buckets still can have outdated policies. There's also an option of having outdated templates. So if you are using, for example, Terraform with AWS provider from, I believe it was 4 years ago, this provider still didn't have secure defaults. So for example, today, when we are creating a bucket with just a name from infrastructure as a code, like Terraform, we will obtain bucket with disabled ACLs, with access public block turned on, and stuff like that, where I believe it was 3, maybe 4 years ago, times go quickly, those templates would still create a bucket without public block or with ACLs enabled. So it was different. Of course, probably all of us know the situation where we are have some problem. We are trying to debug, like something doesn't work, and you are just coming to a conclusion, oh, let's try to open it just for a moment. And this moment stays for the whole history of the company until somebody makes use of that. There are also mistakes. Like if you've got complicated policies, you can make some weird mistake with maybe not action or deny policy, which will basically allow everybody else to access your bucket. More popular example is also just leaking keys. Like, if you think that won't include you, I'm 1% sure that if your company have more people than maybe 2, there is a chance that somebody would fail, and just by accident, maybe, I don't know, he was sleepy, he was exhausted, he will just upload those keys to the repository or maybe to even JavaScript code. And there are also, of course, old classical vulnerabilities. Like, we can, for example, host something on EC2, and then let's say there's server-side request forgery. We are still using metadata service version 1, and we are able to exfiltrate the IAM role, which has access to S3, which then, as you know, we can do a lot more than. So also there is one more thing with ACLs. This is current. Can you say it? I'm not in the picture. So this is how currently we can view the ACLs of bucket. But do you know what was different a few years ago? Does somebody remember what was different? So, yeah. Yeah, exactly. So right now there is anyone with an AWS account. And well, basically it's very direct. What does that mean? If we will enable it, then anybody who has an AWS account can access the files. But the old many was a little bit more not so direct, like any authenticated AWS user. And basically, a lot of people thought, well, they for sure mean that those only include our users of our account. So a lot of people were using those options and basically making their buckets public. Even if we will see into the documentation for CLI options, it's also very well authenticated read. I would say it suggests not the thing which is really done. So where do we start? How we can even search for the buckets? I don't have beer, but water is also enough. So if you know, probably, you can access buckets through different ways. And there are also different URL addresses. Because how many of you knew that to the same bucket we can access through all of those 4 URLs? One of these is needed to be enabled, like S3 website is only when we are enable S3 hosting, but others are always there. So we can access the bucket through virtual host path or by path hosting, I believe it was called. And knowing that, we can start searching internet. Because, there is also one star, and the star basically says that it should be deprecated, but it's still accessible. So if we will go to this path, we'll obtain some information that there is permanent redirect because this path is not supported anymore, but it still shows us that the bucket exists and we can access it. So with this 4 thing, we know now how we can search for the buckets. There's also another thing. There are also HTTP headers and sometimes even DNS records. So for example, if the web page is hosted from S3, we'll have server Amazon S3 information in HTTP headers. If the website is using S3 hosting without like CloudFront or something, and they are just using, for example, CNAME records, we will see in the DNS records that this is also S3. And why we need that? Because with this knowledge, we can easily search the internet for buckets. Of course, we can go through different APIs, like for Google, Yahoo, VirusTotal, Bing. There are like tens of this, or we can just automate it using one of the already existing tools. There is, for example, Sublister, which goes through a lot of those APIs and searches for our string. So we can basically just try to search for S3 Amazon AWS.com. That would be enough. Or we can try, for example, bucket stream, which is just using certificate transparency, reading all of the certificates that are created, and then tries to access buckets with the same names. So if you are creating, for example, a web page and creating a bucket with the same name, they will know about it in like seconds after creation. Of course, there's also Wayback Machine and Common Crawl. And believe me, after 1, maybe 2 days of scanning like that, you will end with probably tens of thousands of buckets. Not all of them will be accessible publicly, but a lot of them will be. There's also another method. We can just do some OSINT. So for example, if you want to be legal, then go to the bug bounty postings, like, for example, what is in the scope of bug bounty of Meta or Facebook. Well, that's the same. Meta, Google, maybe some other companies. Go through URLs, then scan those, and try to see if any of those resources is maybe S3 based. Or just old-fashioned brute force. So for example, there is even a script, lazy S3, which we can try running. And by the way, the screenshot is from yesterday, so if somebody wants a free bucket, it's available. And as you can see, it's publicly visible. So enough talk, let's go to the demos, and the demos will be live, so pray that everything goes right. First, we will try to catch some freshly made bucket and also take a look on one prepared before, which is theoretically not visible publicly, but it is. So, yeah. In my background, I was already running bucket stream. I've started it at the beginning of my presentation, so I believe 20 minutes ago. And already we have a lot of findings. And as you can see, there are buckets which, for example, are already all users read. And we can, for example, try to access it. Because why not? So yeah, like it was 10 minutes, it was enough to find already public bucket. I hope this one is supposed to be public because PDF documents doesn't seem right. Yeah. No, I don't want to close it. So a second thing, I have a bucket here, which I prepared before, which if we want to try to access it, we will obtain the access denied. If we will go to definition of this bucket, we'll see that, yeah, I turned off block public access because it's really working well. So with that, I wouldn't be able to do that. I've also disabled ACLs. Only, well, this is enforced, so we cannot use ACLs. But I've tried to create some weird policy, which at first sight seems right, but at the end it isn't. So I've mixed not actions with principals and denies. And basically, well, there is not action delete bucket to everyone. So we can think that, okay, maybe that blocks anybody from removing this bucket. There's also not action get and list. And who can guess what this combination does at the end? As you can see, this is the same bucket here. I cannot access it publicly. I can even try to refresh it. It's still access denied. So any guesses? Exactly. So I believe I have this in my history. So when trying to access with authenticated account, because there were wildcards on AWS, this combination of not actions, denies, and everything ended it opening the bucket to public. And right now, for example, I can access this beautiful secret, which I really don't even remember what was there. So let's see. I hope it is readable, yeah? Or should it be enlarged? Great. Yeah. So we can read the file. I hope at least we cannot write to the bucket, because I didn't want it to end with a little bigger bill after the presentation. So let me also just close the scanning in the background, because it takes a lot of network connection. And let's continue. So I've shown you the ways of how we can search for those by yourself. But you can always just pay, because there is already a service which is going to the whole internet and gathering all of the buckets. And not only, because there are also Azure blobs, Google Cloud Platform resources, Alibaba is something new. Well, the screenshot was from a week ago, I believe, so this is the current state of it. And as you can see, there is 20 billion files, of which I believe 3 billion are right now still accessible. And these numbers can go quickly. So, okay, we have a bucket, we have access to the bucket, we have maybe read, maybe write. What next from perspective of an attacker? Well, obviously we can steal it. So that's already, I would say, a good thing, at least as I'm saying, from perspective of an attacker, not defender. And we can do it quickly by just using AWS Sync, and that will be enough. Or we can be more, we can have more interesting techniques. Like, for example, if we have enough access, we can create bucket replication policy. And the bucket replication policy will allow us to basically get the whole bucket and get all of the updates in the future. So if you don't know that your environment was taken over, or if there is some malicious insider, then I'm able to just get every new file there is. And there are other methods, because we've got, for example, batch operations, which will be probably quicker than AWS Sync. We have data sync, which also would be quicker. Or we can just generate pre-signed URLs to every file and download them. Even if we are trying to lock our S3 in the VPCs, then, of course, it depends on the access of the attacker. But if the attacker can deploy Lambda or deploy EC2do, he can just deploy those, access the S3, and exfiltrate the files through different ways. Because, for example, we can use DNS, which usually is enabled even in private subnets, which, by the way, in case of AWS, if you are using the default VPC, there is something called DNS, AWS managed DNS, which is enabled. Even if you will block all of the security groups, all of the firewalls, all of the access lists, it's still enabled. So you can request through this DNS to outside of your private network. Or we can use S3 server logs. So we can, for example, enable server logs on our account and use those to exfiltrate the data, because we will be using basically AWS backbone, like a backend, to communicate. And we can then access our server logs to see what was requested. And the requested things would be exfiltrated files. The other thing, which is pretty popular with different groups, is ransomware. And there are also different ways how we can do an attack with ransomware. So the one which was abused a lot was through use of SSCC, so server-side encryption customer. And basically that meant that when uploading a file, you could specify an encryption key And then AWS, before putting the file to the bucket, would encrypt that. It's not KMS. It's not a key from AWS or anything else. It's the key you specify during a request. So basically, after overwriting files like that, nobody is able to decrypt it without the key which probably attacker created. There are other methods because we can use KMS. There is a little plot hole because if you maybe know, if you want to delete the KMS key, there is like 7-day prevention period. And basically, because those keys are in AWS backend, if we will request AWS, they will help us and they will decrypt the data. But if we won't notice for 7 days that something happened, well, it's gone. It's completely gone. And KMS can be used from different accounts, so there are no barriers for that. And there's also another method in which AWS cannot help, so use external key store. Because if you don't know, I believe it was 2 or 3 years ago, AWS created a new service. AWS basically said that if you want, you can create your own KMS on your own architecture, infrastructure, where you have, like, for example, your hardware secure model. So if you don't trust us or if you have some compliance issue, just host your own encryption keys. That's okay. So as an attacker, I can simulate the hardware secure model. And if I have proper access on the account, I can add it to the victim's account and then use those keys from my own infrastructure from different network to encrypt the files. And then just disable the proxy or just turn off the encryption service. So again, the victim won't be able to decrypt the files. And that's our second demo, but I will be using the simpler version with just KMS to show you that it is just so easy and quick. So I've got here some random bucket with like 30-something files, I believe, which is publicly blocked, which don't have any policy, and which has access control list disabled. But I'm assuming that I've stolen the role. And I've stolen the role for here. Send the role to some demo S3 user, which has only access to this bucket. And let's say that he also has some KMS access because maybe we're encrypting data. So it's normal that he would have those accesses, like generate data key and decrypt for any resource. But I have another account here. And this is the attacker's account. So in attacker's account, I have my own KMS, my own key, where I've specified that this user from another account can use this key from mine attacker's account to generate data keys, but only that they cannot use decrypt. And what we can do, let me enlarge this. I have there a simple POC which is using S3 victim, so the leaked keys and the key I've generated in my attacker's account, and using only client copy with this key, I will show you how everything goes broken. Let's just show you that there are real files there. So this is the bucket. I can access it. I can show the content. But after running the ransomware, which takes, It's a wrong region. Oh, it should be in the same region, and I think I've just failed that because this is in. Yeah, the demo guts are not on my site today. It should be the same. It's also the same. So why it was working yesterday and not today? Okay, so I think the demo won't work because I can debug it in a few minutes. But basically, if I would have policies right, which as you can see is easy to make a mistake, that would encrypt all of the files. And because user don't have the decrypt privilege, then I wouldn't be able to access any of those files because basically AWS would say to me on the copy request that, sorry, you don't have access to the decrypt. And because nobody on the victim's account have access, the files are lost. Okay, so let's go to the next scenario. And the next scenario is overvision of public files. So for example, we can overwrite, for example, JavaScript. And well, if you are hosting some SDKs, that can be disastrous because you are basically running a malware to thousands of clients. And this already happened with Twilio, which is, I believe, hosting a lot of libraries for chats, WebSockets, stuff like that. And they have this issue 6 years already, when one of their production buckets, which was hosting the JavaScript files, was public. And somebody noticed that. They've written to those JS files, basically making every web page who was using this task router, they were printing something in the console because they were very lucky that it was discovered by a white hat, which just wanted to show that it is possible and not to create some catastrophe. But if overwriting, we can also overwrite, for example, as I said, templates, for CloudFormation templates. And if we have access, like, for example, to with lick the keys, which has access to the template bucket, and we can create a notification, then on our own account, we can create a Lambda, which is listening for notification from the victim's bucket. And if the victim tries to modify the template, we will automatically overwrite the template and add some new, for example, role accessible from outside, which will have, let's say, administrator access. So basically, that would create a backdoor which is not visible from the victim's account, at least in the moment of creating this template. And I hope that this one will work, because this one is a little bit more complicated, but I've also have some helpers. Okay, so this one I will be using Paweł, a tool for basically making the attacks simpler. And what I have, let's see. First thing, let me go to Lambdas. And in Lambdas, I shouldn't have any function. Yeah, that's correct, because I don't have anything right now. And on the side of the victim, I have a template folder with some create IAM role template. So what we want to do is go to Paweł and run this resource injection template. So maybe let me, so run this resource injection template where I'm specifying attacker key, which is to the account of the attacker, and S3 access key, which is account of the victim. That will create a Lambda with notifications to the CF templates bucket. And I think this one is working, so great. So right now, it's creating a Lambda in the attacker's account, which will be listening for notifications. And it went good. Okay, first step works. Something new. So let's go just to the functions to confirm it. Yeah, and I've got a new Lambda here. And this Lambda, if we look into the code, just quickly go over it, if it will load. AWS, I believe in you. Yeah. So it basically what the code does is figuring what type of the CloudFormation template it is, and it will try to upload, update. Yeah, it will try to see if in the body there is already our injection, and if not, it will add a new body, add role bytes, which loads the template and then injects a new role. And the new role would be this beautiful IAM role, assume role to our own account, and with action resource to anything. So now let's go to our victims. And victims will try to create some new CloudFormation stack with existing resources. And we will use our already existing bucket. It's hard to do this with one hand and with microphone. And I think, oh my God, nobody wants to work. Will it work like that, or also no? Wait. Yeah. Okay, so we have our template, which was very hard to get it. And this template creates just an IAM role, and it's read-only access. It's a demo role. That's all. There's nothing else. So let's create a template, confirm a different bucket we want, because we want to be using our very vulnerable bucket. Confirm and continue. Great. Whatever what the name, a very important role because that's one of our parameters. And yeah, everything is all right. Let's just continue. And of course, because it was already mentioned, AWS has this notification that something changed, but well, we are just changing it. So probably we've changed it, yeah? So just let's accept the change and submit it. And when we look into the resources, there is a new role, which was basically added automatically, but our Lambda. And if we will go to the Lambda, we can see in monitoring and in logs that if the logs will load someday, and we've got logs from today, and basically there was the init because we obtained the notification that there are new changes in the bucket and that we've injected our new role automatically. So with just an access to buckets, we can own the account if we are lucky. Okay, let's go. So I've also said that we can take over the subdomain. So because S3 can be used to host websites, and we can connect S3 to, for example, CloudFront, what do you think would happen if we would remove the bucket but leave the CloudFront? Sorry? Yeah, but the CloudFront would be still pointing to the bucket name. And because bucket names are global, then if we know the bucket name which was used previously, we can create a new bucket with the same name and start hosting new content from the domain of the victim. And I also have a demo for that, but I don't know if we have time, Maria. Okay, great. So this one will be a little hacky because I will show you in a moment why. Okay, let's first confirm that we have our demo hosted here under AWS UG Kraków sub, and we have our CloudFront instance here with origin pointing to the AWS UG Kraków sub bucket. And what I'm gonna do is, theoretically, I should remove this bucket and start hosting a new one. But there is one plot hole, because AWS clears the bucket names like every few hours. And we don't have 4 hours to wait for a new bucket. So I will create a bucket with a little bit different name and just change the origin to show you that we can point to different origin. That would result in the same thing, but yeah, as I said, it needs to be a little bit hacky. So let's just go to the subdomain. Don't I have apply here? Great. So I've already prepared my template to create a new bucket. And this bucket would be called, from what I believe, sub2. This is here. Let's refreeze these buckets. Yeah, we've got AWS UG Kraków sub 3. Normally that would be the same name, but as I said, I cannot do the demo in real time if we want to use the same bucket. So I will go there, and the only thing I will change is the origin name to sub 3. I'm not changing anything else. So normally that would be still the same bucket which was removed. Also, the thing I need to do to speed things up, because CloudFront is using cache, of course, we need to invalidate the cache, because right now we will still be seeing the old web page because of the cache. And after a few seconds, or during my tests, it usually was few seconds, we'll be able to see a new web page. Great. So right now, we can see that under the same domain, at the reload, we found our content. And this is very simple because it's just HTML. But normally, because we've taken over the subdomain, and because how, for example, cookie works, if we have control over subdomain, we can upload some JavaScript files and try to send this domain to our other victims, which after accessing this subdomain, we will be able to steal the cookies from, for example, their session in the upper level domain. Of course, there are some controls, and we can control to which domains cookies are scoped. But by default, they will be scoped to all of the subdomains. And just by this simple trick, we can probably steal some accounts. Yeah, so there are also other things that can be done, or we don't have time already. So I was mentioning exfiltration through server access logs. We can also use S3 to enumerate account IDs, because there is a trick with using ACLs, which we can use to basically get any account number from public buckets. In case of application, stealing data through wrong pre-signed URL generation flow, or invalid upload policies, because if you don't know, there's also something called upload policies. So basically creating HTML forms which can upload files based on a token which was generated, or second order subdomain takeover. So we cannot take the whole domain, but maybe there are resources linked from some bucket which was also expired. And at the end, quick recommendations, what can be done to make the world better. So for S3, there are a few things. On production, for sure, we should enable block public access, or at least for all of the buckets which are not supposed to be public. And usually, if we are even hosting something from the bucket, we can enable it and just use, for example, CloudFront to make it private. We can use S3 versioning to limit possibilities of overwriting the files or deleting the files. But we have to keep in mind, without lifecycle policies, we can end, as Avihay said, with terabytes of data because of thousands of repeated files. Or if we have, for example, limit of 3 versions, the attacker can just create 5 overversions. So it's still possible to overwrite. For compliance, we can use object locked. So basically, write once, read many, and that would disable any option to remove those files. We can use MFI delete, but to be honest, I've never seen this one on production because it's very hard to use. We can use access analyzer to verify if we don't have public buckets. Of course, least privilege principle, never give like wildcards options to different principals, or limit access to at least some VPCs, because in case even of public bucket, if it's limited only to internal VPC, without other vulnerabilities, we cannot access those. Of course, we can also use resource control policies and service control policies, and restrict actions like server-side encryption with customer keys to limit actions like put notification, put replication. We can also block creation of this external KMS storage. So there are options to make our at least production accounts pretty locked out from those scenarios, which probably we won't be using in our day-to-day operations. So it won't impact us. Or we can just make an exception to, let's say, some Jenkins or similar accounts to be still able to call those actions, at least until the time the Jenkins leaks. And of course, logging detection. So enabled CloudTrail for crucial buckets, and for crucial, I mean, for example, with our Terraform templates or CloudFormation templates or some compliance data, we can enable data events to see if there's some leakage going on. We can try to monitor for the more unsuspected actions, like create custom key store or put lifecycle configuration. We can use AWS config to monitor compliance with our own policies. GuardDuty also is able to detect some of the weird movements on our account. Or we can also, well, we should check our CloudFront and Route 53 for any dangling records. So records pointing to non-existing buckets anymore. And of course, at the end, we should do some pen testing on assessments. We can use open source tools like Prowler or Checkov to check things on our accounts. And that's all from me. Under the QR code are all of the URLs you've seen during the presentation. And it's a QA time. So do we have any questions? There's one.
I have one small question, but thanks for the presentation. Is it any difference? You showed a lot of leaks, but is there any difference for different tiering of S3s in the security reason?
From what I know and from what I've seen, no, because all of those tierings have basically the same access controls. So the only difference maybe would be if you are using Glacier, the attacker cannot access the data instantly.
Okay. Thanks.
Anyone else?
So, oh, one more.
Hi, thank you for presentation. It was really cool, and you've provided a lot of information about how to prevent those attacks. Yeah, but imagine you know that you're under attack, you are being exposed, so maybe there's some cool, let's say, playlist from you of exact actions you should take in case you suspect and know that your data is being leaked right now.
Okay, so first problem is that if we are looking at server access logs of S3 or even data events, they are usually late, like 15 minutes or even 30 minutes. So it's hard to detect it right now. The demo that didn't work, the one with ransomware, would show you that basically the encryption can happen in, I believe, 5 or 10 seconds. So it's a very quick thing, which, well, if we leaked, probably we won't block it easily. If we somehow see that, maybe that there was some quick lock or something like that, or we've got really huge bucket which cannot be encrypted in terms of seconds, the only thing I know which works correctly is, I believe, just locking out through, for example, service control policies, any access to the buckets or to resource-based policies, to just kill everything at this moment for this account which is under the attack. Because if we will try to lock out single role or single bucket, there is still a chance that the attacker already have another access. So the best way is to lock out it on the organizational level, and then try to go around to find out why it happened. Because, well, maybe it was just a stupid leak through GitHub code, but maybe there is some vulnerability in our code, in our applications, and the leak was coming from there. and then we have like deeper problem to solve. Do you have another questions?
Thank you. You said a few times about the pre-signed URL. It's a really good flow. And what are the best practices to secure our buckets with the using the pre-signed URL flow with the post or put flow? How is the best from your side?
Okay, so the pre-signed URLs I was mentioning is, well, if you obtain pre-signed URL, it's secure. You cannot like change it to other resource. But if you control how pre-signed URLs are created, that's the biggest issue. So basically, we should verify from our code what is given to the generation process. Because very popular vulnerability is path traversal. So for example, we are making path avatar user X, and then just adding ... the escaping to the previous folders. If we are not validating what was given us by the user, and if we are sanitizing the path before sending it to the pre-signed generation, we will generate basically to the different resources. And I remember it was 1 or 2 years ago, there was one problem in, I don't think they went public with that information, so I think it should be, it should stay, I should stay quiet what was the company, but they had the same problem that when you tried to get your avatar, they were generating pre-signed URLs. So basically what you can do was during the upload of the avatar, specify different path to go to the root folder, and then you will obtain in your avatar the link to the listing of every file from the bucket. And they were mixing avatars with normal like data, which were using users uploading it. So basically obtained the link by that.
Thank you.
Do not trust users' input. That's the best thing you can do.
Any other questions?
Okay, so I think that's all. We still have quiz going on.
Yes, exactly. So take your time, and the quickest and the best answers will be rewarded. So
yeah, so
let's start.
I think we've got like, let's give 2 minutes for people to
Yes.
to end the quiz if you still want it, and then we'll go with rewards.
But we have something more, because as I promised, we have some giveaways for the most active people from this session. So I think, Paweł, that you agree with me that this guy
That was already
exactly,
2 sessions, so
another cap and t-shirt for you.
right. So
Yes. So
I think also the person at the end.
yes, I agree with you. It's for you.
Do you want to give away more?
And a guy who got something from the previous session, but still is the most active one. Thank you.
Hey, congrats to you.
And I get back to,
So
to
2
my
minutes.
station.
2 minutes
Yes.
for quizzes. Yeah.
Exactly.
So in 2 minutes, we will announce who won the quiz. So people which are here will obtain the item reward with the voucher,
Yeah.
and the people who are online will obtain the vouchers through email.
Yes, every voucher is worth $50 for AWS services to use.
And as always, it's AWS, not Amazon. You cannot buy things with that. But at least you can maybe, I don't know, try to get some cryptocurrency or something. So in 2 minutes, we'll be back.
I guess so. Moment, give me a second. All right. So mail.jura.n, Yuri. Okay, so next
could you repeat
next
maybe?
guy for voucher.
Could you repeat the email?
Mail.jura.n, gmail.com.
Okay, I don't think
Okay.
nobody wants it, so let's go. Let's
Mhm.
continue.
Next guy is Puo Piotr Goods. Piotr Goods.
What goods 1313?
Yeah.
Oh, there was
Ah,
two people
okay.
wanted to get it. Should we start to validate it? Yeah, come.
Mm-hmm.
I'm joking, but I saw the second arm. Great, thanks. So
Okay, thank you. Okay. Next one is Newkers.
Newkers?
Yeah.
Newkers. Oh, we've
Newkers.
got Newkers.
Mhm.
Great.
Thank you. M Victor O23. M Victor.
Let's go. Great. So this is different size or the same?
This is how your
L.
mails sounds different. M Victor. Yeah.
Great.
This is-
So you can come
Okay.
for an item also.
Mhm.
We've got just else. So let's get this one with the
But maybe you can share with
Yeah, so
exchange
go
with
with that.
someone.
together with the hat. Yeah.
Mhm.
So that's for you. Ah, thanks. Congrats.
Okay,
And
congrats.
the
Next one. Maciusik.
my let's go.
Hmm.
So we still got the t-shirt for you. Congrats. Thanks for taking praise. And
Winogradowa Olga.
yeah, but the rest are obtaining only vouchers because we don't have
Only
items already.
or maybe something much more crucial.
Yeah, so,
But
so
Olga Winogradowa, are you there? Okay, so
congrats. Sorry,
congrats.
we cannot give you anything more,
And
but you
you-
got the voucher.
And you get a voucher by your email.
And that was the last person, or we still have...
1, 2, 3. Yeah, and that's it.
Okay, great.
Thank you very much.
So thank you for today's attendance. Thanks, Cloudinary, for being here and giving a great talk. And I hope to see you during our next meeting.
Yes.
Thanks.
Thank you very much.
What you gonna do? What? Do you wanna go down? Huh? What you gonna do? Do you wanna go down? What you gonna do? What? Do you wanna go down? What you gonna do? Do you wanna go down? What you gonna do? What? Do you wanna go down? Huh? What you gonna do? Do you wanna go down? What you gonna do? What? Do you wanna go down? Huh? What you gonna do? Do you wanna go down?
Because I'm a beast, I'ma marry you. Flying from the east to the west coast. Make love on the beach with no curfew. If you are a big fish, I'm a shark. Feeling like it is the scenario. Flying from the east to the west coast. Make love on the beach like a sea star. If you are a big fish, I'm a shark. And I go with the sea stars. And I go with the sea stars.
What you gonna do?
What?
Do you wanna go down? What you gonna do?
What?
Do you wanna go down? What you gonna do?
What?
Do you wanna go down? What you gonna do? Do you?
Cute girls on the towel doing yoga. Gold chains on my wrist, you know I told you. Weekend on the boat in California. Please kiss me while I hold you. And so we're going down, yelling hell yeah. On you just because I can't help it. You know we've waited for this a long time. Now everywhere we go is my hometown. This is just a gift for my long travel. Cause I have to live my hometown. And I go with the sea stars. And I go with the sea stars. I will be with you till I die. When I'm with you, it's alright. I'ma be with you till I die. When I'm with you, it's alright. Gotta find a way home. I wonder why no one wants to come. I wonder sometimes if you really want to come. Cute girls on the towel doing yoga. Gold chains on my wrist, you know I told you. A weekend on the boat in California. Please kiss me while I hold you. And so we're going down, yelling hell yeah. You just because I can't help it. You know we waited for this so long. Now everywhere we go is my hometown.
Easy, easy. Pour out your heart to me. Easy, easy.
Pull out your heart to me. Easy. Easy. Easy, easy. You break the bridle to me, losing control. Easy, easy. Crush what you're holding to me. Go easy. Easy, easy. Burn all your things to forget. Easy, oh easy. Burn all your things to easy. Easy. Easy, easy. Pull out your heart to me. Feel alone. Easy. Pull out your heart to me. Feel alone.
da da da.